the only conflict of interest I have is that I lost a parent to hospital-acquired COVID. And I just want to thank you all for being here and caring about infection control, because nothing will bring my parent back. And the reason why I'm here and involved in this is partly because of that personal issue. Many of you know, some of you don't know, I was involved in mask research quite a lot during the pandemic. I want to sort of take you into the academic space where we professors and PhD students and researchers kind of beaver away looking at published papers and trying to bring them together in systematic reviews. And it is an absolute mess. So we published a paper recently, and if you want to scan the QR code, you can download it. But it was called Synthesis Challenges, and we looked at 66 systematic reviews of mask efficacy. Hang on a minute. 66 different teams around the world have done a systematic review of randomized controlled trials and other evidence on mask efficacy. And do you know what the weird thing is? Roughly half of them conclude that masks work and that respirators work better than masks, and roughly half of them conclude the opposite. Hey, what's going on here? What's going on? So we got a grant. We got a grant from UKRI, UK Research and Innovation, to look at this question. What is the efficacy of face masks in reducing transmission of respiratory disease? And of course, there's lots of different respiratory diseases, lots of different kinds of masks. So there was a kind of composite question. But there was also a methodological question, which was what's the best way of doing this? Because the literature is a big, big mess. Different people do different things when they're looking at masks. And then there was a technical question, which I'm not going to tell you about right now, but the most interesting and cool bit of this study is we did use AI. It wasn't in the grant application, but we have been using AI for that, but that's not the bit I'm going to tell you about today. I'm going to tell you a little bit about something called evidential pluralism. And what evidential pluralism says is we need more than one kind of evidence. We need evidence of association, and that's basically if one thing changes, another thing changes in a way that correlates with that. For example, in a randomized controlled trial, the experimental group do differently from the control group. So that's evidence of association. Evidence of mechanism is evidence of how that effect is achieved, or indeed what's interfering with it being achieved. So what we developed was something called mechanism-informed narrative synthesis. And it was inspired by what I called the overwhelmingness of evidence on mask efficacy. And the evidence was overwhelming for all sorts of reasons. It was overwhelming because of the size of the data set. There were well over 300 different studies, although only 26 randomized controlled trials. It was overwhelming because there were multiple different study designs. It was overwhelming because it crossed many disciplines. It went from physics, material science, behavioral science, lots and lots of different kinds of disciplines. There was multi-level causality. There was a web of causation. It wasn't just A causes B. It was A causes B through A1, 2, 3, et cetera, et cetera. There were, of course, emergent interactions between the variables and the context. That's a big academic mouthful, but what it means is, if you were working in hospitals, the wave was going up and down. Certain things changed. The original form of COVID, of SARS-CoV, turned into a different form and a different form and a different form. So all sorts of things were changing. People's willingness to wear masks changed over time. And a lot of this stuff was technically very difficult to understand. I'm not stupid. I tried to learn as much as I could, and I still can't. I reckon in those 300 studies, there's probably half of them I still would say I can't really understand what they're on about. Now, I was inspired by this amazing book by a philosopher of science called Nancy Cartwright. Nancy lives in Oxford. She's now 82. I was around her house the other day, and she's still writing and she's still receiving awards. She's absolutely an incredible lady. And she wrote this book about science as a tangle. And what she meant by that was that no single scientific finding could just be plucked out. You have to look at that finding within all the other relevant scientific findings within which that finding makes sense. And I think one of the problems with mask efficacy trials, once you start putting them in systematic reviews, is you sort of pluck it out and you say, this caused an effect size of this much. Yeah, but hang on a minute, can we just unpack what the context was? And so plucking quantitative findings out of their context says this philosopher of science is a bad idea. Not necessarily Nancy, but other philosophers, and I'm not going to tell you too much about the philosophy. I got the grant with a group of philosophers. It's all very interesting. I haven't got time to tell you about it, but basically the associative findings from either RCTs or observational studies make a lot more sense if they cohere with the mechanistic findings. Look at the kind of stuff that Hilary is presenting, like the genomic analysis, so, the healthcare worker, and then you look at the genetics of the trait, the strain that the patient caught, and you can sort of trace that through. That's all kind of mechanistic data, really. So if you pull it all together and tie it together in a coherent story, it's going to make a lot more sense than if you simply produce a forest plot. So this is a diagram of narrative review. Now, narrative review got a bad press a few years ago because they said, well, narrative review is the bad form of review and the systematic review is the good form of the review. And I still hear that quite a lot. Sure, a badly done narrative review is a bad review, but a badly done systematic review is also. What's the good bit about narrative review? It's these two loops. So what you do is you look for some studies, and then you find a few ones that you think, oh, those are what I want. So you start to summarize them, and then you go into this analysis and interpretation cycle. You actually read them and think about them and try to pull them together. And then that takes you back into searching for more studies. And you go round and round this double cycle a lot of times. This is the kind of review that seeks clarity and understanding, and that's actually what we needed in mask research. It's not saying we're going to get the point estimate. It's saying we're going to make sense. So anyway, we did that. And actually, we've got a 5-step method for mechanism-informed narrative synthesis. You can see that my hierarchy of evidence is a little bit different from the Cochrane collaboration's hierarchy of evidence. Because if you put randomized controlled trials right at the top and everything else below it, anything that's ever won the Nobel Prize for Physics is considered bad evidence. And most of the science that's won the Nobel Prize for Medicine will be considered bad evidence. We have to think beyond the idea that the RCT is the best possible design for everything. It's not. A good RCT is great. I owe my life to an RCT, but that's not the point. Okay, so the next thing is you start to produce this explanation and clarification. For example, you pull together all these different kinds of evidence. What have we got? We've got some physics, we've got some behavioral science, we've got some material science, etc., etc. We've got some mathematics, we've got some epidemiology, blah, 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 blah. That's not fully comprehensive. You guys can have these slides if you want. I don't know how you get them, but you're welcome to them. Here is one example of one mechanistic study, which I picked at random from those 300. There's nothing special about this one, but you can see the kind of evidence that was excluded from many, many of those 66 systematic reviews. This is simply saying that asymptomatic people have been shown to shed virus. This is really important evidence. So then what we do in step 3 is that we develop some bespoke critical appraisal tools using AI. I ain't going to tell you how we do that, but soon we'll be publishing this. Here is an example of a bespoke critical appraisal tool that came out of the generative pre-trained transformer that I was building in ChatGPT. And again, it's not perfect. It's probably not even the firm version, but we made loads of these for different study types. So we then apply those tools to appraise the individual studies, lots of human checking. You don't just set it running and go to lunch. You have to check everything. Here's an example of the kind of stuff that comes out of the AI. This came directly pasted in, and then a human has to check every bit of it, but it's much, much quicker than going through these studies on your own. And then we synthesize and we pull that together. And for example, we've only done the community studies yet. We've got the healthcare worker studies still to come. But within the community studies, we found, well, there's 7 different groups. I mean, for example, the mass gathering ones are amazing. If you want to do research on infection, a really good place is the HARG. And so we put all the HARG studies in one bin and summarized these separately. Okay, so I'm going to give you a few empirical findings. As I say, I've only got the community studies, which is a shame because you guys are a hospital, but you'll see the idea. So the first finding is that mask efficacy relies on multiple linked causal pathways. Okay, a number of mechanisms. So first of all, there's pathophysiological mechanisms and environmental mechanisms. Then there's physical and material mechanisms, and there's equations for these. There's loads and loads of evidence for these mechanisms. There's behavioral mechanisms. There's mechanisms by which adverse effects stop people wearing the mask. There's epidemiological mechanisms. So we unpacked all those, and we pulled them out, and we used AI to help. So that's the first finding. The second finding is that these mechanisms explain how the findings of primary studies got distorted. Design flaws in many of the randomized controlled trials. So people were testing crappy masks, low filtration masks, baggy masks, masks that didn't fit people. Another thing was misaligned exposure windows. I mean, you guys know all about that. You think, why'd you do the study like that? Underpowering. If you're going to do a randomized controlled trial, it usually takes you about 1.5 years to get it off the ground. And so you do your sample size calculation on the basis of, oh, look, there's a lot of flu about, or there's a lot of COVID about. By the time your study starts, you've only got about 1/10 the disease prevalence that you had when you did your sample size calculation, which means your study might look big, but it isn't big enough. So many of those RCTs, even though their sample size calculations look okay, are actually underpowered. Confounding. I could literally talk all day about confounding, but I'm not going to. But we unpacked all the different confounding influences. And again, AI helped us do that. Post-allocation biases. Just because you've randomized doesn't mean there isn't any bias, because after you have randomized, you can get biases introduced. For example, people in the control arm saying, well, I'm going to wear a mask anyway, or people in the intervention arm saying, well, I'm not going to wear one, even though I'm in that arm. And differentials testing. Anyway, I'm not going to tell you about the detail, because I want to keep the overview. This was what we called a temporal causal map. And again, I'm not going to, you take a picture, everyone. I'm not going to talk you through every bit of it, but this started when I got interested in something called directed acyclic graphs. And I moved on from those because the trouble with a DAG, as they call it, it doesn't allow you to unpack mechanisms. It just draws arrows between something that might cause something. But this is a sort of adaptation of a DAG. And the thing about causality, the thing about causality is if something causes something, the cause has to happen before the effect. So temporality, time, is really, really important. And when you have these observational studies of whether someone was wearing a mask and who was infected and who was exposed, it's really important to work out what happened first. So there's an awful lot of epidemiology there. So what we've got here is The brown bit on the left is things that happen before the causality window. Then you've got the causality window in the green, and then the blue bit is after the causality window, and there's all these different things that are going to affect. And you can see it's pretty complicated, but actually that's a very simplified version of what we've got in the paper. I'm going to move on from there, because otherwise I'm going to go over time. So the third finding is that confounding in observational studies could sometimes be adjusted for. So you could say the only trials we're going to look at, or the only studies we're going to look at, is these 26 randomized controlled trials. But actually, the 150 observational studies, quite a few of those are good observational studies, and you can adjust for confounding. We actually got the AI to help us do quantitative bias analysis. We had all sorts of clever quantitative calculations that someone was doing, not me, because I'm not particularly good at sums. But actually, this proved a very powerful technique for distinguishing between observational studies that you could trust and observational studies that you really couldn't trust. Okay, so what was our empirical conclusion? I'm not going to give you an effect size because there isn't one, okay? There's consistent evidence that face masks can meaningfully reduce transmission of respiratory diseases under certain behavioral and environmental conditions. That's a very fancy way of saying they actually work if you wear them. But if you don't wear them, they don't work. Also, if the environmental conditions are such that there is no disease around, there is no COVID around, there is no flu around, guess what? You're not going to get any difference between the masked and the unmasked people. Nobody's going to catch anything. But, and this is a really big but, multiple residual biases, substantial variation in all sorts of these underlying conditions mean that the point estimates of efficacy, the amount that the mask might reduce your risk of catching whatever disease it is, we cannot say that there is a transferable point estimate. Then we'll never find it. Not only will we not find it, nobody will ever find it, because the real world has far too many variables, and they're all changing dynamically. So we've got some papers that we published. Most of these are actually still under review. The whole approach of mechanism-informed narrative synthesis is still under review. We have published the paper on those 66 systematic reviews. And then this last one at the bottom, which you might not be able to see because of the chairs, we've published a paper called The Randomized Controlled Trial as a Cultural Product. And what we mean by that is that these different RCTs were undertaken by different groups of scientists with different backgrounds for different reasons, and they baked in their own assumptions. So, for example, many of the RCTs that were done in a hospital environment were done by hospital doctors who had assumed a droplet mode of transmission. And as you know, that droplet dogma was very, very pervasive in some segments of the IPC community. And so that drove the design of particular versions of interventions and particular versions of the trial. And we've unpacked all that, and the paper actually came out today as I was driving up. So that's absolutely hot off the press. You're the first people to hear about it and get the DOI. What are we doing for the hospital part of the data set? Well, we've published one little paper in the BMJ. This is about non-inferiority studies. The problem with doing a study saying the respirator is non-inferior to a mask is that the non-inferiority studies tend to be subtly biased towards the null. In other words, it's very, very hard to disprove non-inferiority or to prove superiority, which might explain why so many people still say, oh no, respirator isn't any better than a surgical mask. So just to summarize, MINS, mechanism-informed narrative synthesis, involves 4 shifts. It involves a shift in review logic, from extract and aggregate bits of quantitative data to explain and clarify. A shift in how we value evidence from a hierarchy to a diversity. A shift in the tools we use. I haven't really talked about that. From risk of bias to mechanisms of bias. How does this bias play out? Which direction and all that kind of thing. And in how we use AI, which again, I say I'm not going to talk about. So that is the end of my talk. I hope I haven't gone over time. No, I haven't. That's good. So thank you.